Hello everyone. In our last video, we saw how to write a program for line follower. We saw two programs, line follower using a thin line or line follower using a thick line. In this video, we will talk about how to program for a light follower. So what we are going to do is we are going to have two light sensors attached to our robot, and in a normal situation, which is we'll consider normal ambient light as darkness. So we will have to calibrate our sensors such that the ambient light, the normal light, should be considered as darkness. And when it is dark, our vehicle will keep on going forward. So when we show light to the left sensor, the vehicle should turn left. When we show light to the right sensor, vehicle should turn right. And when we show light to both the sensors, the vehicle should stop. Now we can do this program in exact same way as the line follower, but here I'm going to use a different way. So let's start the program. We are going to control the vehicle, so we need vehicle motor library. So Curio Fire motor, create the instance. I give name as V semicolon. I need two variables to store the value of two sensors, and the values are integer values. So int ls comma rs semicolon. So I have done my declarations, and now we'll go to write the program. In setup, we are going to set the pin modes of our A0 and A1 pins, which are the pins connected to the Curio Fire boards sensor/servo 1 and sensor/servo 2. And now we will read and store the sensor values. ls is equal to digital read A0 and rs is equal to digital read A1. So out of RSCA, RS is done, and now it's time to write the C and A, which is compare and act. Now here we need 4 actions, so 4 comparisons. For comparison, we are going to use if ls equal to because it's a comparison. We use double equal to for comparison, single equal to for assignment. Now we are going to check if it is darkness, so which is 1. And because it's an and type of comparison, both the sensors should be reading dark. rs equal to 1. What's the action? Vehicle should go forward. Library command preceded by the name of the instance. We'll keep the speed a little slow for ease of control. Now let me copy this because I'm going to need the if statement 3 more times. So now I'm going to check if the left sensor is reading the light, which is reading 0 value. If left sensor is reading 0 value, I'm going to stop the left motor. Left stop, no speeds. So the moment I see light on left sensor, I'm going to stop the left motor. Right motor is moving, which means I'm going to turn left. That is how I'm going to turn left. And similarly, when I see light on right sensor, if RS is 0, then I will stop right motor. Right stop. And I don't need to write the fourth condition. Why? Because both the sensors are experiencing light, then both the motors are going to stop, left and right, isn't it? So that's how I'm going to stop vehicle. So with 3 commands itself, I'm able to program 4 actions. Let's compile this program. Don't want to save it now. It's compiled. So upload this program and check out whether it works as desired. Before we leave, let's revise this. So we added the CurioFire motor library because we want to use the CurioFire motor library functions. We created an instance v. Then we declared two variables ls and rs of type integer. We set the pin mode of our pins A0 and A1 where we are attaching our sensors to input. Then we read, we stored. We compared, we acted. Read, store, compare, act. And here we have used a different method. We have just stopped the motor to turn that side. And that way, within 3 commands, I am able to write 4 actions. In our next video, we will talk about ultrasound sensor.